So today we would be solving Leetcode question number 54201 matrix. So the question basically says is that we need to find the distance of nearest zero from each cell. That is, from this zero, the distance of nearest zero is 0. Same. For this cell, the distance of nearest zero is 1. And again, all went to 0. For this cell, it is 0. For this cell, the distance of nearest zero is 1. For this cell, it is 0. For this cell, it is 1. For this cell, it is 2, because we will be going from here till here, from here till here, from here till here, from here till here. And then for this cell, this would be again a 1. So we would be approaching this through a BFS approach, a vector. Let us declare a vector of int of direction. What is directions? Directions is all the number of possible directions we can visit. We can visit a no change in row or a one change in column, no change in column or a -1 change in row, no change in a -1 change in row or no change in column. Okay, or we can do any number of pairs like this, like no change in row, one change in column, no change in column, one change in row, one change in row, no change in column, one change in column, no change in row, and similarly we can do all of them. So what we can say this, let's take M is equals to matrix dot size. Let's take N as matrix at 0 dot size, and that is it. We would be declaring a queue of pair int comma int q. Now I would be iterating over int r is equals to 0, r is less than m, r plus plus. For int c is equals to 0, c is less than n, and c plus plus. If I approach a 0, if matrix at r at c is equals to 0, then just store this indexes in my queue. Q dot emplace r comma c. Else just assign matrix at r at c equal to -1. Okay, now iterate over my queue. While q is not equal to empty, while q has elements, just take r and c from q dot front, pop these front values that we have taken, and a semicolon this way, and iterate over all of my directions, these directions. For int I is equals to 0 up till I is less than 4 and I plus plus y4. The directions occurs in pair, so if at any moment I would be here, I would require this, and if I am at this one, I would not have any of the pair. Okay, int new row is equals to old row plus dir at I, comma new column is equals to old column plus dir at I plus 1. I told that these two occur in pair. Okay, now if any of the thing, if new row goes below 0, or new row goes beyond m, or new column goes below 0, or new column goes beyond n, beyond or equal to, sorry, beyond or equal to, that is also not acceptable, or matrix at r or at new row at new column is not equal to -1, that is it was a 0, then just continue. Okay, else matrix at new row and at new column is equals to matrix at old row at old column plus 1, and q dot emplace my new row and new column. What we did is that if I had a cell that was able to reach a 0, of which I have stored these zeros, their indexes. So if I would have occurred with this 0, if this 0 would have occurred in my queue, then moving in any of the directions would not have given me 1. But if I encountered this 0, moving towards the down would give me a 1. So I would just say, just assign that new row and new column that gave me 1. 1, what is the index of 1? The new row and the new column, because that was not equal to -1, that was equal to -1 means it had 1. So I can say that I can reach this one from my this row and this column by just incrementing a distance of 1. Okay, and please just emplace this one also in my queue, because there can be a situation in which there would be a 1, this one for example, that cannot be directly reached by any 0. So in that case, this one would help me reach 0 via this one. So this one would lead to 0 via this path or this path, whatever may be the shortest. Okay, and at the end just return my matrix. I think that is it. Compilation error auto q dot front. Okay, sorry. I think this would be accepted for int. Acha, int nahi, we didn't put int. Okay, that is, I have attempted too many times. Okay, accepted. I think this would be accepted. Yeah. So now moving towards the dynamic programming approach, let me just reset this all. Okay, let us declare int m is equal to matrix dot size, number of rows. Int n is equals to matrix at 0 dot size, that is number of columns, and that is one more thing, infinite is equals to m plus n. Okay, iterating over each and every uh, value of my matrix. For it, row is equals to 0 till row is less than m, and row plus plus for int column is equal to 0 till column is less than n, and column plus plus. What I need to do, if matrix at row and at column is equals to 0, then just continue that is it, that is nice, that is the right spelling. Yeah, else just take my movement, my top movement as infinite, my bottom my left movement as infinite, and then just basically ask, if I move towards a, a row a row up, that is if r minus 1 is greater than or equal to 0, then I can just say top is equals to matrix at r minus 1 remaining at that column C. If C minus 1 is greater than equal to 0, then I can say that left is equals to matrix at that row, just moving a left column, and at last matrix at R at C is equals to minimum of top comma left. Okay, I will be explaining why I am doing this. Let me just, for int R is equals to matrix, for int R is equals to m minus 1 up till R is greater than equal to 0, and R minus minus for int C is equals to n minus 1 up till C is greater than equal to 0, and C minus minus and if a matrix at R at C is equal to 0, then in that case just continue, and if it's not, then just declare int bottom is equals to infi and right is equals to infi, and then just ask if moving a row plus 1 was is less than m, then just say matrix at R at, then just say bottom is equal to matrix at R plus 1 at C, and if moving column right, that is C plus 1, is less than n, then say right is equal to mat at remaining at that row, incrementing the column, then just say matrix at R at C is equals to minimum of matrix at R at C, comma minimum of right comma bottom, and we are doing a movement, so a plus 1. Yeah, that is it. Return mat, and if there would be any error, that would be because of spelling, else the logic is pretty much clear. Or because of this. Okay, I think we are good to go. This is semicolon. Okay, this is it, yeah, and that would be accepted. I will take just 2 minutes to explain what we are doing actually. Okay, a 71 millisecond compared to a 95 millisecond, that is an advantage. Okay, so what we are doing basically is that whenever we are at 1, we just say how many distance how much distance it will take for you to reach 0. If you are 1, how much distance it would take for you to reach 0. He said that let me check my above cells. He checked for the upper cell and for the left cell, so they both had 0 values. So they both were saying for us to reach a 0, we will take 0 moves. Okay, 0 moves. So for you to reach a 0, you just need to reach us. So for this to reach these cells, just add a 1. Okay, now, okay, he said okay, it's good for you both. Now let me check my bottom and the right one. He said how much distance are my right and bottom cells are taking to each 0. So he's the bottom and the right cell said that we both are taking 0 distance to reach a cell that is 0. So you need to just take a distance of 1 to reach us. Okay, then you can reach 0. For in this example, what did this one said? This one said how much distance are my up and the left cell are taking to reach a 0. So up and left cell said that we are taking a distance of 1 to reach a 0. That is sure. He said okay, let me check for another option. He said what is the number of distance my right and the bottom cell. Bottom is nothing. So what is the distance my right side is taking to reach a 0? He said I am taking a distance of 1. So from these both, he said that if you both are taking 1, then for me to reach a 0, I would take a plus 1 distance from you all. So that would be 1 plus 1, that would be 2 at this moment. Okay, and that is the minimum value for any of these three paths. 2 would be minimum. Okay, and that is the logic behind this question. So hope you like this one and my explanation. If you like, do leave a comment down below and share your thoughts in the comment section. Do like the video if you loved my explanation, and do subscribe the channel for more such content. See you in the next video. Bye bye.